Hey guys, welcome. Yeah, so it's fitting in example 3 that we prove the formula for the sum of the cubes of the first n integers, and that's this formula. In example 1, I showed you how to prove the formula for the sum of the first n integers, and that formula was n times n plus 1 divided by 2. Notice that this formula is exactly the square of that formula. So that's an easy way to remember this formula if you want to impress somebody. Okay, so the proof. We start with case 1 as usual. And here n equals 1. So on the left-hand side, we just have 1 cubed, and that's 1. And then on the right-hand side, we use a formula where we replace n with 1, and we get 4 over 4, which is also 1, so we're good. We're going to skip case 2 and go to the all-important inductive step, where we let n equal k. And in this step, remember that we assume the given statement to be true. That is, in this case, we assume that the formula works. So if we want to add from 1 cubed to k cubed, it should be this. And that's in accordance with the formula we wrote at the start. Yeah? Okay, cool. So in the next step and final step, the k plus first step, the left-hand side will look as follows, which is we want to add this time from 1 cubed to k plus 1 cubed. But wait, in the inductive step, we assumed that we know how to add from 1 cubed to k cubed. In fact, we wrote down the formula for it right there. So to simplify this sum here up to k plus 1 cubed, why don't we first replace this with what we know it to be true based on the inductive step, and then just add on that last number, k plus 1 cubed. So that means we write this. And here, to simplify this further, all we have is like a little bit of algebra, which is getting a common denominator of 4 and then factoring out a k plus 1 quantity squared. And once you've done that, you get this, right? And again, you get here simply by writing, multiplying this by 4 over 4, and then factoring out a k plus 1 quantity squared that's here and built in here leaves us with this. Now look at this group of items here, k squared plus 4 times the quantity k plus 1. That's k squared plus 4k plus 4, but that's a perfect square binomial, namely k plus 2 quantity squared. So once we take care of that, we can write this. Okay, cool. So this is all brute force adding, right? We literally added from what we know up to k cubed, and then we, did arithmetic to add on this last guy. We did algebra actually, but yeah, we added this last guy on. We didn't use the formula, right? This wasn't using the formula replacing 1 cubed to k cubed. That was merely using our assumption. Using the formula means we start with the formula, which is that if we want to add up to k cubed, we know the formula is right here. And so then if we want to add up to k plus 1 cubed, then we should just plug in k plus 1 in place of this k here and that k there. So this is using the formula. So when we use the formula, look here, that's k plus 1 quantity squared, and then this here turns into k plus 1, which is k plus 2 quantity squared. So using the formula agrees with our brute force adding. Yeah? Cool. And so we've completed the inductive proof because this here is the same as this here.